This video is a continuation from our part 1, where we started looking at how to use calculus to solve maximization and minimization problems sourced from real life situations. So in part 1 we looked at this first example where the profit of a company is modeled by this function. We saw how to use calculus to find the point that gives maximum profit. And then we looked at this problem from the world of packaging, and we saw how we can use calculus to find the dimensions of a box that is going to have maximum volume. Here we are going to look at these two problems which we gave them to you as an exercise in the previous video. So in the first one, we've got the height of a bullet, which is shot upwards. So we're going to start with that one. So in number 3, we've got h of t equal to 120 t minus t squared. So if you have if this is the ground level, bullet is shot upwards and then it comes down. So the t is the number of seconds after which the bullet was launched upwards. In a part 1, we want to find the height of the bullet after 40 seconds. So we do that by simply plugging t is 40 here. So we're going to have 120 times 40 minus 40 squared. If you punch this in the calculator, times 40 minus 40 squared. 40 squared. So that's going to give us 3,200. The height is in meters. I think the question did not quite specify that, but yes, the height is in meters. And then after 80 seconds, if we do the same calculation, we find that the height is still 3,200. So if you like, what this is saying is that after 40 seconds, the bullet is going to be, say, here. And then after 80 seconds, it's going to be the same height, but this time it's going to be going downwards. Okay, so 3,200 meters in both cases. And then after 120 seconds, we find 120 seconds, we find that the bullet is going to be back at ground level. So the height is 0 meters. So we want to find the maximum height. Maximum is going to be always a stationary point. So we'll start by finding the derivative. First order derivative is going to be 120 minus 2t. Second order derivative is minus 2. This is negative. So second order derivative tells us about concavity. So this is telling us that the function is always going to be concave down because this is a constant. Okay, then for the stationary points, we take the first order derivative and equate it to 0. It's telling us that t is going to be 120 over 2. So the maximum height, this has got to be maximum because the graph is always concave down. So the maximum height is achieved after 60 seconds. After 60 seconds. And that maximum height is going to be given by, so we can find the height by simply plugging in 60 in the height function. 120 times 60 minus 60 squared. So 120 times 60 times 60 minus 60 squared. So this gives us 3,600 meters. So that is going to be the maximum height reached by the bullet. Alright, then in the next example, number 4, we are given that the cost function of a company can be modeled by x squared plus 2000 over x, where x is the monthly sales, number of monthly sales in thousands. We want to find the minimum, the value of x that minimizes the cost. So find number of units that minimize the monthly cost. Alright, so again we find the first order derivative. Derivative of x squared is 2x. This is the same as x to the power minus 1. So if we multiply by minus 1 and subtract 1, this is what this thing is going to look like. Then while we're here, let's find the second order derivative. So that one is going to be 2 plus 4,000 over x cubed. Then for the stationary points, we take the first order derivative, equate it to 0, and solve. If we take the 2000 over x squared to the right hand side, it becomes plus. Then we take the x squared to the left hand side. Then we have 2x cubed is equal to 2000. So it means x cubed is equal to 1000. Then the cube root of 1000 is just 10. So is this a maximum or a minimum? We're going to have to substitute this into the second order derivative. Here is the second order derivative. So it's going to be 2 plus 4,000 over 10 cubed is 1,000. So it's going to be 2 plus 4 is going to be 6. It's greater than 0. So that is telling us that at that point the graph is concave up. So that is, it's giving us a minimum. Okay, so x equal to 10,000 units give a minimum or minimizes the costs. 10,000 units minimize the costs. All right, so that is that. Thank you for watching. Hopefully this is useful. Please do subscribe, of course, so that you can get notified whenever we post new material. Thank you.